Hello, sir. You're not audible.
Second.
Can anyone hear?
Yeah.
Okay.
Can you hear me now?
Yeah, now I can hear.
All right.
Yeah.
So just score is basically, let's take that we have two students who got 172 and 34. Basically, when we compare these two scores, obviously we can say that 172 is much bigger, isn't it? So the student one has got better marks than student two, right? Recording this. uh, Student two. But thing is that let's take that the student one is basically from another school one, maybe school A. And this student is basically from another school B. Okay. But this 172 is not really, it's the same scale. You can see that basically this, okay, yeah, these are the marks. Score is 172, right? Let's take that this one is basically out of 200 or maybe 300. And this one is only out of 40 or 50. Then it is difficult to judge which one got better marks because these two are totally two different scales. This one is out of 300, just assume that it's 300, and this one is out of maybe 50. So if these are two different scales, it is not manually possible to judge which one is better. Okay. So by just by looking at score, we can say that obviously the student one is much better than student two. But out of how many marks, that matters a lot, right? If it is 50 and if this one is, let's say, 300, then it doesn't make any sense comparing these two scores, just scores. Just consider that the average marks that he got is 165 for all the subjects, and the standard deviation is 10. And in this case, the mean is, the average is 30 and standard deviation is 5. So we need to calculate just score. the formula for Z score is X minus mean by standard deviation. We have mean here, standard deviation here, and of course the X. So if we calculate these values, 172 minus 165, 172 minus 165 by standard deviation, right? That is what Z score tells us. And this one is 34 minus 30 by 5. And what we got here is 0.7 and 0.8. This one is 0.7. And this one got 0.8. So out of these values, obviously the student, actually this student 2, student 1, okay? Out of these two students, student 2 got better marks, even though he got on 34, but it's out of what matters. Again, the mean and standard deviation, if we have those values apart from the actual value, then we can calculate standard score and then we can compare these two things, right? Any questions on Z score?
Sir, means,
Go ahead.
hello. Yeah,
Well-
sir, when for student 1 and student 2, when that means out of marks was different, in a different, only that time we can use the Z score for the means, checking.
Yeah,
that
when
which-
these two are in two different scales, then we
Two
are going
different
to
scales, yes.
yeah, scale. The scale is different.
Okay, sir.
All right. The next one, you can ignore this part. We will discuss this later. This one. Next one is correlation. We will see how to calculate correlation later. For now, just by looking at the visualization charts or or the numbers, we need to find out how. I think we discussed about correlation, isn't it? This indicates that it is a positive correlation. So if one increases, the other one also increases. You can see that in upward direction. And this one is basically if one increases, the other one decreases. So it's downward direction, negative correlation. This is positive correlation. This is completely scattered out. So there is no upward or downward trend. So it is neutral. So in this case, it's going to be around 0. Whereas in this case, it's going to be -1. It's going to be a +1. So usually correlation is going to be in between -1, 0, +1, right? So when we say that y in and as, let's take something that has high correlation, we can easily, yeah, you can see that 0.86, right? Flavonoids and phenols. So there is a high positive correlation. So here it's not negative, it's positive. So if it is near to 1, we can say that it is strong. Even if it is, in this case also it is positive, strong, but it is negative. Whereas in this case, it is positive. Whereas if it is near to 0, in and around 0, it is neutral, right? So by this, is there any other high positive correlation or high negative correlation near to -1 or +1?
Minus that flavonoids and wine.
Flavonoids and yeah, this is a high negative correlation, right? If flavonoid increases, wine decreases at a rate of 84%, 84.7%, that is 85%. Decrease at the rate of 85%. Okay. And is there any other thing? So basically, like if a data frame dot
Wine
for
and flavonoid.
which one?
Wine and flavonoid data.
Yeah, this has already been said, right? So is there any other
Oh yeah.
one?
I mean, I took that set. Sorry. Yeah, same thing.
Is there any other column that has high positive correlation or high negative correlation? Or you can take any value and explain it. Whether it is positive, negative, neutral, or near to 0 means there is no correlation. That is what it means. Neutral, I mean to say. Is there any other one?
78% is there one OD from the last second. Yeah, that one.
OD and wine. So which means if OD increases, what happens?
Wine decreases like that.
At a rate
Negative,
of,
right?
yeah, decrease
Minus
at a rate of
78%. 78%.
78.8. That is almost 79%. Right?
Yeah.
Yeah. Is there any other one? You can take any value and explain what does that mean. Let's take that this one is flavonoids and hue. So what does this mean? 0.54 means
Both are increases with the percentage of 54%.
if one increases, the other one
Also increases.
Increases
at a
positive
rate of,
54%.
when we say
One.
increases, it obviously means positive. So
Yeah.
at a rate of,
54%.
yeah, 54%. And it means that it is not really strong, but almost like I can say in medium kind of, right? This core method will give, like if you apply it on the whole data frame, this is the data frame name that we have given for this one. If you apply it on the whole data frame, then we are going to get the complete correlation table for every column combination. Obviously, if it is the same column, you're going to get the same one, right? It doesn't make any, so you can completely ignore this diagonal part. Alcohol, alcohol, malic acid, ash, ash. It's obviously going to be one. You can ignore this part. All right. So, and if you want, I think we discussed about paid plot, isn't it? I think in
Yeah.
paid plot, we discussed what is correlation. Yeah. So this is, so what does this mean? This
Positive.
particular
Positive
positive
correlation.
correlation, right? So it is actually strong positive correlation, I can say. Between what is this? Phenols and I don't have the column name. Okay. But this basically, if it is the same column, it's going to give histogram, right? The next one is the models. Models is basically if you feed data to algorithm. 1 second, let me. All right. So when we feed data to algorithm, so it's going to, we can get the model, isn't it? Model is nothing but a kind of pattern. It is going to be presented in the form of, model is going to be presented in the form of function. So basically this function or pattern or model is going to help us in finding out the pattern, right? So if you, in mathematics, model is also a kind of function. It is exponential model. Exponential model in the sense where data is growing at like this. Data is growing in this form. Okay. And if this is, if it is like this, it's going to be linear. This is linear correlate, it's linear model. This is exponential model. Logistic model is going to be like this. Basically, we use logistic model for classification problems. And anything that is above to this one threshold, it's going to be let's take this one. Sorry. So they will have some threshold. Anything that is above this one is going to be B class, and anything that is below is going to be A class. This is one of the models, logistic model. Basically, that tells us what kind of data that we have. So which pattern it is in, right?
So what is there any meaning for A class and B class or just naming?
No, we will discuss that in classification issues. Like basically, when we have, let's take apple and banana. With the given data, we need to judge whether it is apple and banana. So with the, let's take that width of it, a color of it, right?
Based on the data. Okay.
So based on the input data, we need to judge whether it is an apple or banana. So we call it as classification. All right, we'll discuss that later. So right now the mod is nothing but a kind of pattern that will help us in understanding the data. All right, so that's it on basic statistics, but we have advanced statistics. Central limit theorem, it may be quite difficult to understand if you read theory. Let me explain, with a more simple example. For example, let's take collection, what do you call exit polls? Okay, exit polls, they have collected data from each of the states. Let's take AP, right? UP, and what else we have? Maharashtra, Tamil Nadu, Goa. What else we have? Kerala, Delhi, and Assam, right? Let's take that T from each state, they collected some data for exit polls. Exit polls. They collected data, basically collected data in the sense they have taken opinion to whom they have voted and why they have voted. They have some sample and the distribution, let's take that distribution is normal distribution. Most of the values are in and around a particular value. So in this case, it is uniform distribution, this particular state. And in this state, it is more of like, it's like this. Or in this case, it is like this. In this case, it is going to be something like this. I hope you got the point, right? So almost like uniform. So it's going to be like this in this distribution. So if we plot graph distribution plot on each of these from each of these states, we may get different set of distributions, right? So it need not to be same. It need not to be all the time normal distribution, bell curve. Let's say in this case, okay, something we got, I'm just giving a rough picture of how things are going to be. Just by with the data, we got different sets of distribution. Obviously, these are not the same set of distributions, right? Same distribution. Thing is that central limit theorem. This basically after several experiments, what they came up with is they came up with a theorem saying that if we take average of these values, so average of all these values, basically we get the data and we plot a distribution. And instead of plotting a distribution, get the average of all these values. Okay, average 1. The same way, average 2, average 3, average 4, average 5, average 6, average 7, and average 8. Now we have how many averages? 8 averages from each of these data. So basically we have taken average of all the data. And again, average of all the data. Any questions up to here?
No, sir.
Now, if we plot a graph on all these averages, okay, we are taking only the averages here. We plot a graph on all these averages, the distribution curve is going to be normal distribution. That is what the central limit theorem says. Why we are so concerned about normal distribution of bell curve? Because statistics assume the data is in normal distribution. Okay, so like Z score, area under curve, probability density distribution. These are all statistical methods wherein it assumes the data is normal distribution. So if it's not possible to have a proper distribution for like this common distribution for all these all the data, then if you can able to take averages, and then if you can able to plot the graph on the averages, then it's going to be normal distribution. So if we have a normal distribution, we can easily apply statistics and get some rough idea like how the data is going to be, right? Got it? That's the whole idea of this. No,
Whatever the distribution it may be, if we take the average of that and plot it, will we get the normal distribution itself
yeah,
at the end?
average distribution of all the averages, not one,
Yeah, yeah,
all
all
the
the
averages.
So it will give a normal distribution at the end.
Yeah, so that is what central limit theorem says.
Okay.
We'll see this later. Next one is central tendency. Central tendency is on an average. Basically, if it's not possible to, obviously it's not possible to see, all the data and get an idea like how things are. So we basically look for like, on an average how things are, right? So let's take that you are not watching a match, cricket match, and someone else, like one of your friends or bunch of your friends are watching. When you call him, obviously you'll try to find out what is the status, what is going on. They give a rough figure. They're not going to tell you this player has scored this many runs and this player has scored this many runs and this many overs has been happened, right? Unless you go in detail. They say that India is almost winning, or maybe it's neck on neck, or maybe say like in the last game, final game, T20 World Cup. So South Africa is almost winning till 15th over, isn't it? 15.2.
Yeah.
And thereafter things got changed. They scored only 1 run out of 4 balls at 16th over. And thereafter they have scored very meager. And the last over became after the Surya catch, Hardik Pandya's bowling. So it completely tilted towards India. So it's basically we are trying to always look for on an average what is going to happen, isn't what is happening. So this central tendency is all about finding out that average. There are a few other means, we'll discuss that later. For now, we will focus on these three. So let's take that we have data like this. Okay. For example, 22, 23, 24, 25, 23, 27, 26, 24. So on an average, what is the value? So let's take somewhere around 25 or 26, 25. Okay, just giving a rough figure. So it's 25, right? On average, this is what happening. And let's take that I'm going to take the same values. But in this case, let's take that I have this thing. What do you think the average is in that case? Just giving a rough figure. Can we apply average? I think I gave you an example during skew distribution, left skewed and right skewed. Yesterday I had given it.
Yeah.
So if government wants to introduce some policy, economic policy to upbring the middle class families, right? Society wherein most like 99.99% are middle class families, and 1% Ambani stays in that area. Then if they go up with this, outliers also, right? Exceptional values. Then the whole average, if they take average, what happens? It is going to give a wrong figure, right? Wrong figure in the sense it's going to give the right figure. It's going to figure, but that will mislead the decision, isn't it? So when we have an outlier like this, we call this as outliers. We will discuss how to find outliers later. So these are we call this as outliers. So when we have outliers like this, calculating mean will mislead the decision. So in that case, we need to calculate median. Median is nothing but we need to sort out these values first, and then whatever the middle value is, that is going to be the median. So how to sort out this? So we have 24 here, right? So 23, another 23 here. And 26 here. So it's been sorted out now. Now, what is the middle value of this? 1, 2, 3, 4, 5, 6, 7, 8, 9. So what could be the middle value?
24.
4.5.
Which one?
Yes.
24.
24, right? So 24 is
24.
going to be the median. So when we have numerical values, if it is normally, if the data is almost like this, then we can go with the mean. Whereas if the data has outliers like this, exceptional values that are not in order of what the most values are, then in that case, don't take mean. Take median. Median is nothing but central value. Or else the other way is remove these exceptional values and then calculate mean. Then it won't go wrong, right? We can take right
But
decision in
those
that
are
case.
also data, right? Can we remove that directly? I mean, it is also considered a data, right?
Yes, it is data. It is also considered as data, but in exception, if we know that it is going to mislead that information decision we make, then it is better to remove it. And we need to find out, and to precise, we need to find out why we got those values. What sort of data it is? Is it by mistake they entered like that? Or is it for some reason, some other reason? In this particular case, it is better to remove because it is going to quite, easily is going to mislead the decision.
Okay.
And moreover, the economic policy, the government, the example that I have given, in fact, if we remove the, like let's say that the policy is not going to be applied to Mukesh Ambani, then it's absolutely fine, right? Even if he has been considered as middle class family member, then it doesn't make any difference,
Yeah.
right? So as long as the decision we are going to get is right, that's fine. Of course, it is part of data. We need to be careful that we should not remove all the outliers. If it is near to, let's take that we have something like 100, then we can ignore that. We can also consider this one, right? So the next one is mode. Let's take, we have values like good, bad, bad, good, bad, good, good. So in this case, do you think that is there any possibility to take average, mean, or median? These are qualitative in nature, right? Isn't it?
Yes, sir.
So
Yeah.
in this case, it's not possible to take mean or median. We should apply mode. Mode is nothing but
Frequency.
high,
Frequency.
high frequency value. So what is the high frequency value here? I think good, 1,
Good.
2, 3, 4, 5. Good is 5.
Bad
What
is
about
3.
bad? 1, 2, 3. 1 second. Right. So the most frequent value here is actually bad is 3 times got repeated. So the most frequent value is good. So we are going to take good. Okay. So this is the mode. What if it is both are same? Let's take bad is also 5 times being repeated, right? That case it is 5 times got repeated. Then we can take any value we want. It doesn't matter. Okay. Is that clear?
Sir, if there was numerical value 1, 2, so, like the same as good or bad, so can we calculate mode for that also based on the frequency?
No, it's actually it depends on the type of data. So basically it's going to be like this. So when we have as per statistics, is going to be like quantitative data is going to be divided into 2 ways, quantitative and qualitative, right? Again, quantitative is being subdivided into 2, continuous and discrete. And qualitative again, these are subdivided into 2, nominal and ordinal. Okay, data qualitative has been subdivided into continuous and discrete. And quantitative, sorry, this is quantitative. This is qualitative. It's nominal and ordinal. Let's take that anything that has, like, again, numerical in nature. Okay, this one discrete is also numerical in nature, right? But this, when there is a possibility of having, not like not to have decimal value, but possibility of having decimal values. When there is a possibility of having decimal values, then we call it as continuous. Let's take the height of students. So even though, let's take that height of student is 5, 6, 4, 5, 5, 6, 4, it still can be continuous. Because we can, if we find out what is the nature of the data, let's take height, then there is a possibility of having 6.2. But in this particular data set, it doesn't contain any decimal values. It doesn't mean that there is no possibility. If there is a possibility, then which is numerical nature, we call it as continuous quantitative data. Clear? Whereas
Yeah.
discrete is again numerical in nature, but there is no possibility of having decimal values. For example, number of members in a family. So is there a possibility of having decimal part? Let's say 2.5 members or 2.3 members or 4.8 members. Is there a possibility of having such number?
No.
Right? Number of members in a family. It can be 1, 2, 2, it can be 3 or 4, 4, 5, or it can be any number that there is absolutely no possibility of having decimal value. So we call this data as discrete. So for discrete data, we need to find out the mode. We should not find out the average, mean or median. So the mean or median is only for continuous data, continuous quantitative data. Okay. Whereas for discrete quantitative data, you should not apply mean or median. What you have to apply? You have to apply mode. Whereas here, you can apply mean or median. When the data has outliers, go with median. When this does not contain outliers, go with mean. If the data is like this, we need to find out the nature of the data first. What is this tells us? So it's clearly saying that it is a number of members in a family. So there is a possibility. You need to you need to question yourself, like, if this is going to give us the number of members in a family, is there a possibility of having decimal value? decimal part. And as I told you before, it means the data that we got may or may not have decimal values. In this case, even though there is a possibility, we don't have decimal values, right? So in that case, when we need to consider discrete quantity data, not continuous quantity data. If it is discrete quantity data, then we need to apply mode. Your question is, what if it is 1, 1, 2, 2, 3, 3, 3 kind of?
Yeah.
Then we need to check what is the nature of the data. If it is anything other than continuous quantity data, we need to apply mode. There is no possibility of having mean or median. Only for continuous quantity data, we need to apply mean or median. Clear?
Okay, sir. Got it. What is nominal and ordinal?
Nominal or ordinal, again, qualitative data, like good, bad kind of, right? Quality data.
Like 0, 1 kind of thing, true or false kind of thing.
Yeah, true or false, good or bad, women, men, right? Quality data, and it won't have any order in it, no order internally. So men, women. So when we have data like men, women like that, men, women. Is there any order between women and men? So
No.
there is no order. So men can come first or women can come first. There is no order. So then if it is qualitative data and there is no order in it, we call it as nominal qualitative data. So in this case, this is nominal quantitative data, right? This gender is nominal quantitative data. Whereas the ordinal is basically, let's take that movie reviews, 5 star, 4 star, 3 stars. Okay? Or 4.5 stars, 3 stars. This is qualitative nature. And this has an order. So 5 come first, right? 4 comes later, 3 comes later, next to 4, and so on and so forth. So there is an order. It is qualitative nature, 5 stars, 4 stars, these are qualitative nature. And yet it has an order in it. Okay?
Yeah, got it.
So again, this has to be, you need to be very good at this to, I mean, the concept that we have explained just now. Those who haven't understood, watch the recording again and try to understand this concept. This is very, very important. It will help us to segregate, like when we get data set, it will help us to segregate what kind of problem it is. Okay. Fine. I hope this is clear. And we will discuss these concepts later, other concepts we have. All right, the next one. Confidence interval may take some time. So we'll discuss correlation covariance. So first we will discuss covariance. Let's take that you have got some data wherein you have height and weight, nothing else. Don't ignore this part completely. This part. You have height and weight. Your objective is to find out if height increases, weight will increase or decrease, or there won't be any impact. Okay. Usually we can say that height increases, weight also increases, right? On an average, I'm telling you, exceptions always be there. Even a 6 feet person maybe is going to have much less weight compared to a 5 feet person. But we have a bunch of heights here and corresponding weight here. Any questions up to here? Height and weight?
No.
And here we need to find out mean of these weights and heights. The mean of height is 175.65. How do we get mean of this? 160 plus 170 plus, we will need to sum up by how many values we have? 1, 2, 3, 4, 5, 6, 7, by 8, right? So we got average for this height. The same way we got average for weight. And we need to calculate standard deviation for this particular column height and this particular column weight. We know how to calculate standard deviation. I think yesterday we have seen. Square root
Yeah,
of
the summation minus
x minus
divided
x,
by
x minus mean whole square as a summation of x minus mean whole square by n if it is population, n minus 1 if it is sample. Okay.
for this kind of data it is n minus 1, right? Sample.
Yeah, for this kind of data, it's definitely n minus 1. All right. So any questions up to here? This part, ignore this part, these three columns. So any questions up to here? Height, weight, mean, standard deviation.
No.
The next one is we need to calculate x minus x dash, y minus y dash. Okay. X minus x dash means, let's take this is x, right? 160 minus 175.625. What is the value? The same way, we do it for all the other values. 170 minus 175.625 minus 5.625. 165 minus 175.625 minus 10.625. 180 minus 175.625. So we need to calculate for all the values. Any questions on this?
No, sir.
The same way, we need to calculate for y minus y bar. So what is y? What is y and y minus y bar? What is y bar here?
130 mean of the
130.
y.
Yeah,
Weight
130
y.
minus 170
170.
minus 625. So minus 40.625. 150 minus 170.625 minus 20.625. I'm going to calculate for all the values. No questions, right? On this part.
No.
Then we need to calculate, we need to multiply these value and these values. So for each of these rows, minus 15.625 into minus 40.625 is 634.7656. So minus and minus, it become
Yes.
positive, right?
Yeah.
Plus. So again, minus 5.625, minus 20.65, we got 116. And so on and so forth. Only here we got negative because one is negative, other one is positive. So that's the reason we got here. So any questions on this part?
Yes.
Then we need to calculate summation of this. So this particular column, we need to calculate, we need to apply addition. We need to get the whole sum, total summation. And this is 1821.875. We got 634 minus 0.7656 plus 116 plus 272. And we keep on adding it like we got summation like this. Any questions? This part, I think this part is clear, right? Now, the covariance formula is sigma x minus x bar multiplied by y minus y bar. So we already have this one. Where do you have this? What is the value of this one? Where do we get this?
Summation.
This
1821.
summation. 1821.875. So we need to find this. And where do we get this n?
Sample, number of samples.
Number of rows, right? We have 8 rows, and but whatever the data that we have taken is not population, it's sample. So we need to apply n minus 1. So what we got here is 260.26785. This will help us if weight height increases, whether weight will increase or not. Can we say by this number, if height increases, weight will also increase?
How is it related to height? I mean, based on the numbers, how can it?
This covariance will help us in the variance between these two. And this will help us like whether one increases, the other one will increase or not. If it is positive value, it means it increases, but at what rate?
It is once we should consider it to height or what 200% more than like that.
No, it is difficult. Obviously, it is difficult to say by this number whether if height increases, weight will increase or not. Right?
Yeah.
So there is another concept called correlation. Now the correlation comes into existence. Basically, it came after this covariance because it is difficult to say by this number if height increases, weight will increase or not. Correlation, there is only one change compared to this one. Let's compare these formulas and tell me what is the difference. There's only one difference between this one and this
Yeah,
one.
in the denominator there is one other value. Yeah.
That is
Sigma
standard
x,
deviation of x.
standard deviation of x
X
and
and Y.
standard deviation
Y.
of y. Basically, what are we trying to calculate? We are trying to divide by standard deviations. when we divide by standard deviation, what happens is we are going to get the value between in -1 to 0 to +1. Here in this case it is positive. So we are going to get value in between these things. What does this mean now?
Yes,
0.99.
it will increase. Yeah, height
If
increases,
height
weight also.
increases,
Weight
weight will
also.
increase at a rate of 99.91%. So most of the cases, almost 100%, if height increases, weight will increase. But by this covariance, we can't say that.
Yeah.
Only when we when we divide by standard deviation, we'll get into this value. So we can get a value between -1 to +1. Here, all the values are positive, so it doesn't make any difference. But if it is negative, then we are going to get, a negative correlation. So there is no difference between covariance and correlation. The only difference between covariance and correlation is that we'll try to bring the correlation in a form of proportion. Okay, by dividing by standard deviations. Otherwise, it is almost impossible with this number to judge whether height increases, weight will increase or not. Right? So, any questions on covariance and correlation?
No, sir, understood.
All right, so it's already 9:51. All right, we'll continue tomorrow.
Sir, one question, sir.
Yeah,
Uh,
please.
the correlation help me to identify that how the two data are related to each other. But then what is the covariance? Why it was required for that one? Only for calculation purpose or is
No, this is the actual concept. But the idea is to find out the relation, right? The variance. If one changes, one varies, the other one also varies. The variance is all about if one changes, so the other one also changes, but at what rate? The core is nothing but between these variances. That's the whole idea. But it is difficult to judge by this number. So correlation came after covariance. So we have this value. They can figure it out that the relation between height and weight, but it is humanly difficult to judge by this number. That is when they started dividing by standard deviation. Standard deviation is nothing but what? Why do we divide by standard deviation? We'll bring it into one scale.
okay?
Then the values will come between -1 to +1. It's actually proportion.
Okay,
Yeah.
sir.
Yeah.
Yes, sir.
It is like, without roots, is it possible to have branches? The same way, correlation is like a branch, whereas
Yes, sir.
covariance is like a root. The correlation came from covariance. All right. Any
Yes,
other
sir.
questions?
Means from this value, I can say that this X and Y are related to each other. Means whether it is a positive or negative, that I cannot say.
No, of course we can say that, but in this particular case, no, I'm telling you the possibility of having numbers. But in this particular case, it is clearly positive. So if height increases,
Yes.
definitely 99.91% weight increases. So there is a possibility if we take some other values, let's take weight and fat. So it may have negative value, right? May have positive or may have negative, whatever. But if we take some other values, so obviously there is a possibility of having negative. But in this case, it's clearly positive.
Yes, that.
So, sir, where will we use this? I mean, the whatever you taught us today.
Just now
So,
we
where
have
will we
seen it,
use this
right?
one?
Just now we have seen the correlation, in fact. Where we have seen this. How do you find out the correlation? Now, the thing is that we can use it in feature selection, most important columns. You will see that in ML internals. If we can able to find out the correlation, high correlated columns, let's take that you and your friend went for an interview. You both have same qualification, same score, same experience, same technology, and able to answer all the questions, or maybe let's take an 8 out of 10. Even your friend answered 8 out of 10, same set of questions. Then who is going to be selected? If they need only one person. Obviously, taking two is going to be overhead.
There has to be some parameters so that they can select like that.
They can pick only one, right? Out of
Yeah.
you both. So it can be whoever can be like with the choice. It doesn't matter. They can pick one person. Same way,
Yeah.
when we have 1,000 input columns and one target column, when we feed data to that particular column, what happens? What happens then? Let's take when we feed data to algorithm. Usually, data means what? There will be some bunch of input columns plus target column. And in this case, let's take that we have 1,000 input columns. So let's take that we have some 120 correlated columns out of 1,000. Then we can get rid of this one, right? Then we can manage with the 880, right? So 880 is much better than 1,000. So we will discuss that in future selection. There will be a session on feature selection itself, ML internals, part of ML internals.
Sir, here algorithm means that correlation, covariance, of those things are here.
No,
Algorithm
we'll
means?
discuss that later. So algorithm, correlation is not algorithm. All right, that's it for today. If you have questions, let me know, or else you can log off. Thanks for joining. Continue tomorrow.
Thanks.
Thank you, sir.
Thank you.
Yeah, thank you.